Okay, good morning everyone. I saw some of your faces already yesterday and the day before, so I guess some of you already started their INSPIRE conference. For all the others, that is now roughly the official start from the INSPIRE conference, so welcome to that. And we start with a technical session here. We have 5 presentations. All presentations are meant to be in time, so you will have a tough schedule here. And we start with a presentation from Francesco from the University of Zaragoza, who will tell us about developing a national persistent identifier management system. Francesco, the floor is yours.
Thank you. Yes. Hello, good morning. My name is Javier Lopez. I'm from the University of Zaragoza. I'm here to show the ongoing work in developing a national PID management system for Spain. Well, you know, INSPIRE recommends us to use the URI HTTP scheme for identifying spatial objects, datasets, and shared resources, more or less. The idea is that below we have an spatial, the PID of an spatial object, you put it into a web browser, and magically it resolves into a download service that provides you or the Gmail file or the zipped shape file. However, this way they say, okay, this should be provided by the referencing, but the problem is that this piece is missing because from INSPIRE they say it's each member country that is responsible to organize this system. This is our blueprint for a national solution. First, we need a business view. We need a governing committee, a technical secretariat, several procedural policies in order to set up this, for example, in Spain. But also need the technical piece, a system that allows to register namespaces, to register PIDs, and also to resolve them into requests to the download services. For the business view, the governing committee, for example, in Spain, should be composed by people that are involved into the INSPIRE movement. They should make the strategic decisions and also decide what is the application scope of this infrastructure. The technical secretariat, in this case will be the National Geographic Institute of Spain, should provide the solutions for the everyday of this infrastructure. And also relevant stakeholders should participate in this movement. On the technical side of the solution, we'll need to have a common schema for our URIs. For example, this one. Also, we need a central registry for namespaces. And also, and this is the most important piece of the system, we need an automated system for gathering all the spatial objects and mint and a proper IDI. And finally, we need the resolver service in order to turn these PIDs into requests to the services. Well, we are going to see some use cases about the use of this infrastructure. For example, for registry and namespaces. It's quite easy in this point of view, because first we can use the namespace registry in order to add one, for example, a new data provider. And this data provider, this request, this apply, is checked by the technical secretariat. And after that, when he can start to work with the system, he might, for example, decide to register a new namespace, administrative units, for example. And then, after doing that, the PID registry starts to harvest all the services associated with this namespace and start to get each spatial object in order to register this spatial object and assign a unique PID. And the next thing is to publish all these PIDs on the web. And the question is why? Because we need that Google, for example, index all these PIDs. Why? Because probably sometime an entrepreneur may discover by Googling something that say, okay, I need something, for example, for an app, some data. And I need the boundaries, for example, for our app. So I found this information in Google, and then can start to use these PIDs into my app. And this app might ask for resolve this PID into something useful. And it will use what? Our resolver. And the resolver will ask the registry, and the registry will provide the request to the download service. And in this point, even the resolver can provide some added value services, such as we can provide this content in different formats. We can even have a proxy, or even instead to redirecting, we can act it as a proxy. So for the final user, the only point is the resolver. This infrastructure provides some useful tools for everybody in the system. For example, the technical secretariat can use the PID registry to monitoring the quality of the data provided by the providers. For example, we can check is the IDs inside of the spatial objects are conforming to the INSPIRE rules, for example. In this case, the technical secretariat can use the information in the namespace registry in order to warn the owner of the data that they have an issue. But also, we can see that users can use, for example, the system for warning the data providers that there is some issue in their data. Also, this infrastructure allows to the whole system to be more resilient, because we know it's more usual than we would like to admit that data moves from an organization to another. For example, due to a merger, a reorganization of administration, and so on. So, in the case, for example, the administrative unit is transferred to another entity that may also decide to even change the technology that is serving the data, the new owner only needs to warn or to update information in the namespace registry, and then the system automatically will update the index, and from the point of view of the user, nothing has changed. The app will use the existing PID, and this will be resolved to the new system. We have the following expected benefits for these solutions. First, with the approach, we can meet the INSPIRE recommendation about the PIDs. We think that this approach could be probably fast adopted by the stakeholder in Spain because we have devised an uncomplicated process. Also, is web-friendly. It's designed in order to be very easy to index it by Google and so on. And we have several added values. We have a proof of concept working from the last year, so the approach seems to be technically resilient. Now we are developing a new prototype whose code is already available in GitHub, and it is a working in progress. The idea is to transform this into a multi-tenancy application that allows to support multiple organizations with multiple users updating the data and providing really a real system for having several organizations working on this. We expect that this framework will be more or less ready in about 6 months, more or less. But the most important thing is, okay, if we have this finished, and somebody want to start to develop the national system, how much it will cost? We expect that the work from the technical secretariat will be only 4 person months each year, plus the cost of maintaining the infrastructure. For finishing, fast, isn't it?
Super. More
Nice.
questions
Well, this is a proof of concept that a nearly automated framework for minting the HTTP URIs is feasible. Not all the cases has been solved. We are working in improving some problems, for example, for, okay, how do you solve the approach when there is not a web service for accessing the data, but only you have a point to download the whole data set? We're working on that. But we think that this idea offers other possibilities. For example, in a way, if this can become, for example, as a proxy, we are creating a gateway for all the network services for a country. Because from the point of view of the users, the service is located at a URL of the system. It is possible to use this for doing that, because you can register the URL of the service, and the same system that is useful for redirecting to a simple spatial object could be used for redirecting to the capabilities of the service, for example. Also, why not to use this for metadata and start to use this inside of metadata? So, for example, you can have a metadata PID that can resolve to the metadata file, so it's not nor link rock, for example, in web services. And even if you do that, you can transform the SDI into a sort of navigable SDIs, because all the links passes through this URI framework. Thank you. Thank you for your attention, and if you are willing to make some questions, I think that we have time, isn't it?
We have time. Thank you, Francesco. It was a quick presentation, and obviously a nice acronym you have already for the URL. Are there questions to these presentations? Please.
How many providers are due to enter the system in Spain?
Now in the prototype, in the proof of concept, we have four different providers. The idea is to develop a prototype that will be able to add any number of providers with different kind of users, with different kind of permissions, in order to have even an internal workflow for approving the creation of an namespace. I think that the main issues in this approach is the size in the number of PIDs. Up to date, and I wish if you have this number, please give to me. I wonder which is the number of PIDs that we require for INSPIRE in Europe. Because when I start to think in this, because our PIDs must stay for many years, we may be talking about billions at European level. And this would cause a problem in the sense of, okay, how do you keep all this data for several years in your system? Because think about this. For example, for land parcels, a PID for a land parcel, the old one, when, for example, the land parcel did not exist anymore because it has changed and so on, is important for probably for administrative procedures in the future, maybe 10, 15, 50 years in the future. And I think this is something that nobody has said, in the sense that I don't see a solution for this yet. And I think this is the worst thing in this. We need to start to think about the size, not of the providers, but the number of PIDs. And I did not this number, so if somebody here in this room has this number, please provide me, because it will be very useful.
Okay, so you have your task for the end of the session, guessing how many objects we have in INSPIRE, spatial objects all over Europe.
Not now, but also in the future.
Please, and don't only use your hands for that. I think you need more. That relates to another question. So you have these identifiers for each unique spatial object as defined by the INSPIRE data.
The idea is to do that because we use as source of information the INSPIRE type, and the idea is just to convert this INSPIRE type into the source of the PID.
Okay, now you know what you count. Other questions to the presentation? And possibly one, if I understood that rightly, then this providing service for the IDs, that is roughly the hook in all your infrastructure. Mm-hmm. So what do you guess, what kind of quality of service would that have to achieve, and how would you secure that? Because otherwise the whole system wouldn't work, if I got that right.
Yes, I know. This is an ongoing project because the problem with that, the quality of the services is really bad. A solution is to transform us into a cache.
Okay.
I mean, for example, we discover that there are some issues in the services, or even we discover that there are problems, we can catch all the data, and then after that, when the problem is fixed, return the data. And this is interesting because in practice, in this approach, for the get object, you don't need to have a real service behind. You can even a source. For example, the case in this case is the case with the dataset that they don't have a WFES for serving. And we are studying to get the original data, the dataset, and transform us into a service in order to serve each piece of data. So when we have this, we also have the solution for the cache and the problem of the quality service not solved but mitigated.
Okay, I see a lot of stuff for the coffee break. We have to stop here. Thank you very much.
Thank you.
And move on to the next presentation. Carlo Cipollino will give us, and will stay with uniqueness here, that is unique identifiers for borehole data. And you come together even.
Yeah.
So a French-Italian cooperation. Even
Foreign presentation to voice
but
presentation.
we still have only 15 minutes to go.
Yeah,
so
I know.
Please, go ahead.
Okay, just to look into presentation. Easier. Okay, perfect. So good morning to all. This presentation is part of a EPOS project. EPOS project is a big project related to the INSPIRE branch. The EPOS is in the second phase, is in the implementation phase. These projects involve 49 different partners, but it's a European research infrastructure, so this project is also supported by member states in terms of especially research, ministry, and in this moment we have more or less 25 countries involved in the project. The project is itself involve many other research national institutions, because we have also the national framework where the EPOS play a role. So in some ways, a very big infrastructure, where mainly is based on the solid earth science. And the idea is to integrate a system future adventure European facility in a single distributed sustainable infrastructure. So to give an opportunity for research, but not only for research, also for the user, for other type of user, the possibility to use and to access to the data of earth science. More or less in the project we have 10 different web pages related to the thematic core service. Each core service have a specific domain. In this case, we are in the core service related to geological information and modeling. So it's more related to geological data in this way. But of course, our data is quite important for other core services like near-Earth observation, volcanic observation, anthropogenic hazard, multi-laboratory, geoenergy, seismic hazard. So we have a lot of different domains that using in cross-cutting system the data to produce new data, new information. So in this way, we try to design some important layer to provide geologic information to the other thematic core service at the beginning, and then to the other people. The objective is to create a unique access in this way for Borehole. So we summarize some Borehole information. We create a simple layer, then we see some example, and provide link to reach the structure information flow. So from the information, from an IT perspective and approach, we not reinvent the wheel, so we reuse what we have. We reuse the persistent initiative, so we have in the framework of one geology project, a GDI project, so we have several projects in the past that using to build the infrastructure for geological survey. And we want to using, of course, the official standard for geology, the international standard for geology, so we're using GeoCML 4.1, that is OGC standard, and this is a real extension, the natural extension of INSPIRE geological data specification. So in some way we're using Borehole view, that is a simple feature, so we not need to go in detail at the moment, but we're using very simple feature to provide the information as well. Asking to Sylvain to explain a little bit the structure, how we organize that.
Okay, thank you, Carlo. Hello, everybody. So, yeah, if we take a conceptual point of view on that, that's the way the UML is organized, is that a borehole is linked to monitoring facility that serve observation, feature of interest being geologic unit or hydrogeologic unit, if we think about aquifers, for example. Our boreholes has construction details and other observation that could be the borehole logs. All these object features are based on INSPIRE and OGC standards, so we don't contradict the definition from INSPIRE. But given, as Carlos said, that there are several surveys providing information, and given that we want to set up a unique access point, we don't want to harvest all those blue boxes. That would be chaos as far as volume is concerned. So, yeah, I forgot that link. So that's why we created that vision of attacking from above, and you will see that in other slides, the system. So yes, this is a UML view. If we move to a resource view, we want our partners, each survey, to implement that with concept being served by OGC services like WFS and observation services, linking each instance by URI as it was presented before. But again, it's in each national system, and we don't want to re-harvest everything. So we defined this borehole view. We reused what was in GeoCML, and the trick is to use that concept and ask partner to serve it, that provide a quick hook to entries within the system. So this is the way it is from an architectural point of view. That's an example of instance. I don't know if you can read it. What is interesting here, it's really, there is no pointer. Oh, you have the pointer there. Each entry is pointing via URIs to control vocabularies, but also to other flows below here, activating the call to complex flows. So basically using simple feature to search for information, then bounce to more complex information. And I guess this one is done, and yeah, that's your turn for the last one.
Okay. We're using this approach, so the first element that we're using is two different identifiers. So in the borehole view, we have the GML identifier and GSMLP identifier. So why are we using that? We're using the first one, the GML identifier, like that. You can see a very simple URI that is not that in some way is resolvable, and is in some way is a teeny URI to not see exactly which is the infrastructure that we have behind. And this one is a simple URI to access to the single feature borehole. The other URI that we're using, the GSMLP identifier, is using to go more in detail. So this URI, this is also an example of an instance of a borehole, is used to go in detail. So to go in the other information that we showed before. So like borehole details with the log, and so more geological information associated to that. In the same way, we're using other URI that in some way we're showing later on, I think so, to enter for groundwater monitoring or environment monitoring. So you continue, or you want to do? Okay. In this way, for example, is an example how we can access to the groundwater information. So we have a specific URI in GSMLP groundwater level that allow us to go directly to information related to the groundwater level. So we have in some way the direct access for monitoring. The same approach is used for geological description, for borehole construction, and observation measurement. So it's used to go very in details in different geological domain to archive all the information associated to the borehole. I think so is, but to comment this is, I mean, this is what we building behind.
Yeah. So, as I said, in the bottom line, each partner is implementing the complex feature approach, serving complex information, plus the simple feature summary information. And that's the only IT content that we're exchanging between national layers and this EU access, unique access point we're building. So basically at EU level, we have a central node in our system that is frequently harvesting national providers just for the simple feature that really simplifies the volume that are exchanged. And we can work at the central node level to optimize the index. I mean, like it's a WFS that is now hosting 3 million entries, gonna explode afterwards. So we want to withstand performances. And we also work on making that duplication of information in some way up to date with what is national level. So that's here comes up the OGC PubSub specification and to trigger just transfer of updated information at the EU cache level. And of course, the borehole view as it's displayed here will be declared in the INSPIRE metadata and Geoportal and etc. I continue?
Yeah.
Okay. Conclusions. So our conclusion of that work is that for many projects, we've been asking our geological partners to expose only complex feature flows and try to harvest that into some kind of central access point. That's a huge burden. It's way easier to ask people to implement simple feature flows. You have more endpoints, and it's easier to synchronize with them. Harvesting simple feature is more reasonable. I mean, WFS is not meant to act for database dump, actually. So, and in a way, yeah, harvesting borehole vCard is just for discovery. The first entry in a system for external people is way more reasonable. So, yes, and then in turn you point to national data flow with respect to INSPIRE semantics, and the index just to support discovery. Perspective. Progressively, we are connecting more geological survey partners. The real target is to make it the unique access point for discovery or European boreholes. From an IT point of view, like I said, now we have 3 million entries. It's going to explode afterwards with more partners. So we are investigating how we can connect the GeoServer with app schema that is serving that to Solar Index, because otherwise things, will collapse. And we also plan, because we mentioned several times discovering, we also plan to explore exposing this exact same content, not destroying the semantic, but with another serialization. So that could be geo in bracket JSON LD, this kind of flavor, just to enable like someone in Google just to Google for I want the borehole in that area and have some feedback. And I guess, yeah, that's the end.
Thank you very much for the presentation, and I guess everyone counting objects already got a number. There were 3 millions to be exploded to whatever, 20 millions.
Yeah, but for 3 countries or 4.
It is just for counting.
Are there questions to this presentation? Yeah.
Hey, I really like the presentation, the SQL feature model. I wonder, so the way we look at this is not just for view or indexing. We think relationship can be browsed through the same SQL feature model as well, like we do with REST or with JSON. So have you thought about that?
Yeah, basically that's what we've got in that schema in URI. We want also our partners, when they expose their complex feature flows, to have that kind of RESTful-oriented approach in their URI. We also were thinking using at some point with that PubSub implementation we're working on. Basically, what's is happening in our test is that the central node should be notified that this URI has changed, full stop. So it could be a fully RESTful-oriented PubSub situation. You change locally something, and you just CRUD, CRUD, notify your central node that this URI should be dereferenced again because the content has changed. So it reduces the machinery to be deployed both at the lower level and at the central node. That answer your question?
If I may add a question to that, I didn't fully get that. So you keep your persistent ID with your spatial object, your borehole, and then the update is done via a service or notification, or do you give a new ID to an updated version of the object?
Actually, the purpose of the borehole view here is not to create information. Here, the green box. So it's up to each data provider in its data management plan to decide whether the change in one borehole is worth changing the ID. Because sometimes, I mean, if you just correct a typo, you just don't want to change the ID of the borehole.
Yeah, I'm with you.
Some needs to be persistent for decades. But in some other situation, you may want to say, oh, I delete this identifier. It does not mean it disappeared from the system. Other flow could still connect to that. But it's not the most up-to-date to be used, so you pushed other identifier in the system.
Okay. But it
And we may want to
one
change
day
that.
to think about a common versioning policy on that one.
Exactly.
Possibly. Yeah. Okay, there's still room for another question. Okay, I guess this counting task is too absorbing. Yeah.
Maybe I'll just make a final remark. What we are looking at, and we were kind of, oh, thank you. I think you showed the GML, not too much the WFS interface or the get capabilities. Get capabilities shows feature types. It could be a table or an actual feature class with some geometries. We are thinking that you probably need at least a way to say this particular feature type is a relationship, some way to express it so that you can simply browse as any normal other application or REST service. So that's the other consideration, because you show mostly the GML, but the WFS doesn't have really a way to express that.
Actually, the XSD of the features will tell you that, the borehole view XSD. If you do describe feature type on it, you will learn what that is.
Okay. Okay, I see another interesting coffee discussion coming up here. And thank you very much again for your presentation and the discussion. And we move on to another uniqueness presentation. This one is on GML. GML IDEU is the acronym for that. And Severin Rousseau will give us this presentation.
Hi. Hello. It's not just an acronym, it's an actual site. You can go to it. It's http://gmlid.eu. So a data access point for short URLs. I'm happy I'm in this slot because the previous presentations just work perfectly with mine. I want to present harmonized access to harmonized data using INSPIRE WFS download services. It's a very, yeah, F5. So it's function. Okay. It's a very long title for a very complicated solution that we found a simple fix to. We want users to be able to use our services to use INSPIRE data. Easy. So we started with this question: what if INSPIRE were simple, clear, intuitive, and easy for users? So not necessarily for data providers, which have to build the entire systems and the SDIs, but for end users. Can we create short URLs in combination with smart IDs and some technical manipulation of existing services with respect to REST and JSON? Right now, we're using WFS and GML. So we should try to find a solution given the current implementation status. So what we're seeing is that more and more member states and responsible authorities are moving towards providing some network services to the data, and we're mandated to provide them. Vector data, I've especially worked with vector data, should come in WFS. Predefined GML datasets are very difficult to work. Cypress took me about a day to download 5,000 GML, individual GML, because nobody thought of putting them in a single archive. So it took a long time to get them. There is no Google for searching in INSPIRE, not really. We have 2 search engines right now which do part of the job. Datasets are usually very large and cumbersome, and users usually want a small subset of that data. They don't want to download millions of entries when they just need a couple of hundreds, or just one data, like the one with administrative unit. And despite being thousands of pages, there is no simple intro to INSPIRE for end users. It's really difficult to tell somebody from an agency how to use and get some data from INSPIRE. So we have one INSPIRE Geoportal. So what we want? We want simple, intuitive, and easy INSPIRE. Simple because right now we're using Geoportals. We have 2 search systems. We're looking in metadata files that lead us hopefully sometimes to WFS endpoints, which then need to be parameterized to finally get the GML data. This is a lot of technical knowledge that end users are supposed to have. They should know about metadata files and what they contain. They should learn about the difference between the dataset metadata and the web service metadata. They should learn about KVP requests. They should be not afraid of post requests. So there's a lot of things that can go wrong for users to stop and not use INSPIRE data. Now, things have to change. So what we propose is a simple, logic-based, clear, and straightforward way to get to both metadata, service endpoints, and GML data. That is intuitive for users and can work within the INSPIRE diversity. Because right now, a lot of member states and a lot of authorities have implemented, not innumerable, but a lot of different technical solutions. So what we want is preferably one domain to bring them all together. We want one rule for standardizing providers and datasets. We want to simplify getting to the GML data and integrate everything. So integrating both metadata for datasets and web services, integrate endpoints, integrate cross-theme datasets. One dataset might have multiple data themes, and we also want them to provide with a simple way of filtering the data. Just like a short example is how to get administrative units now. You should go on the INSPIRE Geoportal, start your search, get the metadata files. Hopefully the metadata files are correctly written and the endpoint there points to the correct get capabilities from the WFS. And then you start to do a whole bunch of parameterizing on the WFS, finally to get the GML data that you need. If this fails, you have to go to step 5, where you go to the proxy browser and you start searching services that refer to administrative units, and you have to get to the get capabilities endpoint and then finally get the data. And for me personally, when I showed users this, they lost hope. They said that this is not possible, this is not feasible. Just give me the GML, or even better, just give me the shape file, give it in a zip file, email it me, and you take care of all the rest. So what would be the ideal version of this process? We would want one domain, we'd want one country, then the provider, then the dataset, and after the dataset, just slash and add more information to get the required information. So we add /md to get the metadata for the dataset, and if we want the dataset, the metadata for the WFS, we just add md/WFS. If we want to use the WFS, we just have the dataset and add WFS. So with WMS, so with GML, and so on and so forth. These are 2 currently implemented rewrites and short URLs that are available through gmlid.eu, especially the ones on the right side for the Ministry of Environment and the Protected Areas dataset, which is composed of 4 data themes, which is protected sites, administrative units, geographical regions, and named places. So we set about having a straightforward logic. So we have for each dataset, each provider in each country, a base URL. The base URL can be any domain. We just registered gmlid.eu because it was available. The country, we already have registries for countries. Dataset providers should ideally be something short, so an international abbreviation of the provider. For example, in Romania, the Ministry of Environment was eENV. The National Cadastre Agency is INSPIRE, which is in Romanian. Even in France, we have the Société Nationale des Chemins de Fer Français, which is CNSF. So there are already institutions which are implementing these abbreviations, and usually data sets have a name. It's in the RS identifier inside the metadata. It's the code and the code space element inside the metadata, and we should use that. So we have our base URL, and then we start adding elements to it. We add MD to get the dataset metadata document. We add MD.wfs to get to the WFS, to the WMS. We can get to /capabilities and get directly to the capabilities file for both for WFS and WMS. And everything happens behind our servers, so behind closed doors. End users do not need to know the exact endpoints where these services reside or these metadata reside. They just want a simple URL that they can use to get the data that they need. So we have the base URL, and then we want to get the GML data. So we just add /GML, and then the system does all the work. But maybe we don't want 3 million boreholes. We just want 10. We just add /10, which in the background specifies to the WFS some parameters just to give us 10 elements. Then we want to start at this 507th element, and we just add another / to it. If we want to go to a specific data theme, for example, in the protected areas dataset, we want to get all the protected sites, or just 10 of the protected sites. We just, after the dataset, we add the data theme, and then we add GML, and then we add 10, and then we add so on and so forth. Okay, so when we started to implement this, we wanted to go down to each unique spatial object. And to go to each unique spatial object, we really need our identifiers to be smart. We need our identifiers to be intelligent. So we have a side-by-side comparison right now. On case 2 is from the National Cadastre Agency, which implemented the WFS for administrative units a couple of years before we did. And on the left side, we have case 1, which is for the Ministry of Environment. So if for the National Cadastre, the GML ID value is used in the identifier link, that should generate the element, and there is no tie with INSPIRE ID right now. On the left side, we've forced and we've constructed all the IDs so that everything self-references. And you get the GML identifier that actually produces the distinct spatial object. And everything is inside the GML. Okay, how does this work? For example, if we want one Natura 2000 sites. I've worked a lot with environmental data. If you want just one Natura 2000 sites, we just keep their name because they already have a very good persistent identifier in the common database. So it might be ROSG 0135, and we just append that to the data theme, to the data set, to the data provider, to the country. So we get the spatial object. Or we might get just a natural protected site in Romania. They had all these different types of names, and we just standardized them. And we can use these information to build a registry of objects, which is searchable by Google, which can be indexed. And then we can have a registry of spatial objects that is readily available for all users with a simple URL. And if you see this URL for this object, you know that if you want to go back to the WFS, you just remove some slashes and you put MD, or you put WFS. And the last part is with life cycles. We've implemented for the biogeographical regions, we've implemented the life cycle system. So if, for example, if you want the latest version, you just add the version, the identifier, which is CON for continental. But if you want the previous version or previous versions of it, you just add the date that you're interested in. And the system, with the stored queries and some rewrites, just searches for the data to bring you the information that you need. Just one small, I would like to bring your attention to this identifier, and I'm not sure, because I've seen persistent IDs presented before. identifiers need to have meaning. If you just have E21, DB, DFF, and a lot of letters stringed together, this is not a meaningful identifier. This does not help me get the data that I need. I know that my county or my country has this code. I know that this information should have this code, right? If you use automatically generated IDs, these will not help you get the data that you want. Okay, so we have access to the metadata, we have access to the service endpoints, we have access to individual spatial objects, but usually for reporting tasks by responsible authorities, as well as users, they usually want a subset of the data. For example, protected areas dataset in the protected sites, we have a lot of designations. But most people just want one of those designations. So you might want to say, hey, I want to query this data theme and give me just the Natura 2000. This is a codeless registry, which is available on the registry, INSPIRE registry. So we know which value is supposed to go here. The same for site of community importance and their official abbreviation. The same can be done with other data. For example, administrative units have this element which is the national level. We know the values for the national level, and we can pre-create these subsets dynamically without having to generate very large amounts of GML. And then we can have these links, and we can give this short link, which is logical, and users can use it to go back and forth in the data, to navigate through the data. And of course, if you want to add count, insert index, and all that, we just append more numbers to these requests. So what we used for the GML ID rewrites is Nginx, which is a very powerful tool. We turn, for example, we turn just an XML, which is found on the web. We've turned it into something meaningful. So it's a metadata for a dataset. It's this dataset. It's protected areas dataset, which is for the environmental ministry in Romania. So we have country, the provider, dataset, and finally file. Similarly, for the National Cadastre Agency, we took the entry in the Geoportal, which is a REST endpoint, which gives you an XML. And we want to standardize it to call it the same way, no matter which technology is used, no matter which provider we are looking at. And finally, this is a request for WFS. This is the geo server that is running that is serving the protected areas dataset. We do not want to start teaching users about KVP requests. They just want to see what the XML looks like or the GML looks like. So we want to take these long requests, which can be sometimes very long, and turn them into very short URLs, which are intelligent and simple to remember. For example, to get GML or to get these specific categories and subsets, we have been using extensively stored queries, which are, unfortunately, there are some recommendations in INSPIRE, but they are overlooked, which they are very powerful tools that give users meaningful access to your data. So for example, if we want a Natura 2000, and I've written here in bold all the parameters that one user might apply to a WFS to get meaningful data. But I don't want to teach users how to do KVP requests because it takes a long time. I just want to give them a short URL that gives them exactly the data that they need. And the beauty of this is that you can create the stored queries remotely. So I've created, for example, the stored queries on the National Cadastre Agency because they didn't have any or any useful. And for those which are interested, I've listed the two most important stored queries that we used. It's the get feature by INSPIRE ID. So INSPIRE ID should be a very important subject to all data providers. This is the actual query that is being run against the WFS. This is the KVP request to that stored query, and this is what we want users to call. So we want users to just use the short URL and not worry about stored queries, not worry about KVP requests. The same thing for the categories where we have this get feature single criterion stored query, which is highly parameterized. And we just want the users to use these short URLs instead of the very long KVP requests. Conclusions and summing up. Homogeneous access to metadata, WFS, web services, GML is easily achievable. Clear, straightforward access through short URLs is possible while using existing INSPIRE infrastructure. This is very important. Member states will not want to implement more technology and more changes to their system because these are expensive systems, very elaborate systems, and we want to use existing technology. WFS GML data provides a wide array of options. If we just have predefined datasets, there's not much you can do about it. You just download it and convert it to something more that can work. Stored queries are severely neglected in the current technical guidelines. And all these might move INSPIRE to more integrated SDI. Let's help users reach the data.
Okay, thank you.
Thank you.
It seemed very restful driven, the presentation, so we have time for one, possibly two questions. Other questions? Go here first, hold back. Yeah, please.
No. So for that's a good session because I had the feeling for years in the conference that topic was overlooked. So it's very nice, hiding somehow the complexity behind, and yeah, there is some kind of RESTful binding to WFS as well. That's fun. Just one question on a remark on your example. It's really serialization bounded. I mean, you mentioned GML, but in a way, in your data set, it may be going down to the URI scheme you're choosing. You could even remove the encoding because it would work for whatever serialization people may want to ask in 5 year time. If you don't change the GML prefix, you will have to revisit everything. Because if an information object of CD is linked to an administrative unit, it's still valid, be it JSON, GML, or whatever.
Yep.
So that would be an advice, and it would be way better aligned with spatial data and the web and data and web practices as well.
So initially when we prototyped this, we wanted to give a zip file with a shapefile. But unfortunately we were using GeoServer and it has some lack of functionalities to turn complex features into simple features. So this is why right now we only have the /GML. Initially we wanted to have a lot more...
yeah, but your domain is GML ID.
Oh, right.
Okay.
I would try GML Identifier or even remove the GML.
Just a general remark to that. There's a good reason in computer science that there have been long quarrels about verbose and non-verbose identifier, and there are good reasons for both. So there's a long history on that one. Possibly you get into that also. And there's a clear point in this discussion. Right?
Yeah.
That is not that easy to solve.
Yeah, sure, of course.
I could fully agree. One tiny question now.
Yeah, very nice presentation. I just have a question. Sometimes you can't make queries with URLs because that's a hierarchical way to reach something, but sometimes you need some more parameters, for example, a bounding box, where you can't go. So have you think about, that's a sort of a AND Boolean query when you go in a hierarchical way. It's not an OR query. How do you solve this? And multiple parameters.
So, yeah, well, you can... Okay, briefly.
And even here, don't get into the REST and SOA discussion because that is roughly the point there. Yeah.
So what I would do if the current implemented queries do not satisfy my needs, I would go to the WFS, I would just make a post, I would just create my stored query there and KVP that stored query. But this is one specific user which is very technical, which might understand the technology behind, and the majority of users of spatial data are not necessarily that technically prepared.
Yeah. Thank you. Clearly, we have different users. Thanks a lot for this presentation, and we move on to the next presentations. The next two are more about compliance than about uniqueness. We move on with Stefania. She's reporting about the eENVplus validation service, and still looking for the slides. Here we go. Yeah. Please.
Okay. Is it okay? Yes.
Yeah.
So, hello everyone. We have heard today about how to identify resources, how to get our resources, and indeed how to identify resources and identifier management is a key aspect for a successful INSPIRE implementation. And finally, I can see in this INSPIRE conference, I've heard many discussions about this, so it's a very important thing. So let me go back somehow to the foundation. I mean, what kind of data are we identifying, and what kind of data are we downloading, are we using? So interoperability of data means that data should be should speak the same language, and you can obtain this only through validated data, and so successfully validating data. May I ask how many of you already have heard about the eENVplus validation service or used it? So I can see if I can skip the general presentation. Anyway, the eENVplus validation service is an online tool to validate INSPIRE data and GML data in general, and also INSPIRE extended schemas and datasets. So the idea behind the validation service was to side with the implementers, as we are small companies deeply involved in INSPIRE, and so we have been struggling to obtain GML validating and validating WFS and so on. So we conceived this tool to side with the implementers with a step-by-step guide, helpful tips, and so on. And what is important here is that we try to fulfill user needs now that INSPIRE has come to the implementation phase, and more and more institutions realize that they may need an INSPIRE extended schemas to take into consideration national constraints, national data models. And we are also providing two different test suites. So for big data with a lighter validation, so validation of a fewer constraints, and the full validation that is available for small datasets, small sizes datasets. So this slide you can have, this is the homepage of the validation service. So with an introduction to the concept of INSPIRE data validation. So with the concept of ATS and ETS, what they are, where you can find them. And so once you have understood this, you can select a theme, a data theme that is relevant to your data set, and you will be introduced to the full list of the abstract tests that you have to undergo to claim compliance, to assess compliance of your data set to INSPIRE. We have not all the tests are automatically executable, so there are some tests that are manual, and for those tests we are providing guidelines for the implementations of the test. And we are also trying to give helpful tips on, of course, what requirements are you validating your data set against, but also about the most frequently encountered issues on your data set. Some very odd ones, for example, the one I opened here, that is the counterclock orientations or counterclockwise orientations of polygons, which is derived from an ISO requirement. So, what can you validate? The conformance of GML resources. That means access the application schemas, so conformance of the application schemas. For example, if you create an INSPIRE extended schema, you can validate here. And of course, conformance of GML datasets. And the GML dataset conformance will be evaluated against all access the application schema defined in your file, your address in the GML files, and also against all application schemas that are imported on turn by your application schema. And you are validating also against INSPIRE constraints common to all data team. For example, if data complies with some code list values which are common to all the teams, like near reason value, for example. And other supplementary theme-specific constraints by means of schematron files. You can see at the upper side the OGC logo. Reason is because the eENVplus validation service is based on OGC GML test suite, which is reused and customized for INSPIRE and INSPIRE extended data by means of schematron files. So, how you can address resources to be tested? By means of course, of a local file, so upload a GML resource from locally, and also by means of a URI, of course, if your file is available on the web, but also by means of a WFS get feature request. So you can test directly the service. So the data exposed by a service by means of a get feature request, or the schema by means of a WFS described feature type request. So I have explained before that it is that the GML test suite from OGC has been customized by means of a schematron file. So you can select a schematron from a drop-down list. The default is the INSPIRE common, so testing requirements common to all data specification. And then INSPIRE data team specific schematrons. And in this case, it is important to understand that we have also schematrons which are related to INSPIRE extended schemas or thematic domain schemas. And this is a new entry for the eENVplus validation service, that is the geoscience ML schematron. So thank you to the CGIs for having provided us those schematrons. We have also the AQD schematrons, so air quality schematrons that have been provided to us. So we make them available online so that the users can test their dataset against theme-specific schematrons, thematic specific schematrons. So we have also two different test suites. That because we have a limitation in the OGC test suite underpinning our service, that is that when files are too big, of course, undergoing full validation, because we have also topological validation, and when we have millions of polygons, you can understand that this may be memory consuming, and our service is likely to crash, so to run into out of memory issues. That is why we provide two different test suites. One that is suited for big data, which is the GML documents conformance test suite, and which verifies the conformance of the big GML dataset, but only to referenced application schema structures. So there is no schematron test, no schematron rules are activated to validate the datasets. So above all, dealing with semantics and proper field values, proper values in the field of the GML. Then to execute an in-depth conformance test, we have to select, you have to select the other GML test suite, which is the GML 3.2 conformance test suite, which verifies conformance to the ISO as a whole. So it verifies all requirements in the GML specifications and adds schematron rules validation. But of course, be aware that in this case, the size of the, you should use, in case your GML size is very big, to divide, so to have small data set and test one by one, or make queries and test WFS, so get data from WFS by means of stored queries, so all that we have heard in the previous presentation. So just a remark here, that it is important to understand that if we leave the default option, the INSPIRE common schematron is executed on the dataset. And so if we don't need any schematron rule, because maybe this is not an INSPIRE schema that you are testing, or you are validating an INSPIRE extended schema or INSPIRE extended schema dataset, you can skip the schematron test or select the most suitable one. So we, of course, have guidelines, I've already said, for manual tests that cannot be automatic. We get users' feedback, so there is the possibility for the user to send us messages and ask us about functionalities and issues it may encounter. We are having continuous interactions with OGC since 2015, so it's almost 2 years, or more than 2 years, that the INSPIRE validation service has been online, freely available for testing your dataset. It is invocable through REST APIs, so it can be embedded in other applications. Additional schematron files coming soon, because also we have requests from other thematic areas to put online their schematrons by means of our tool, our online tool. And we also try to be more useful for the user, setting up an help desk, an INSPIRE help desk, and you can visit us at stand B2 there and have a more in-depth visit to the eENVplus validation service. So thank you.
Thank you, Stefania. For all the ones who wouldn't find your booth, there's no time for questions. So if you have the questions to the presentation, go ahead. Possibly a question on the performance issue. Are there any plans to get that solved? I mean, some megabytes of data are not.
Well, the limit now is, let's say, 100 to 200 megabytes for the deep validation, so for in-depth validation. For the other test suite, we are having no, let's say, no size issue. So we have also validated up to tens of gigabytes, so having no issues. Related to your question, that is, are we thinking about solving the issue, is, let's say, it does not depend on us alone, because we are depending on OGC test suite. So we have had many discussions with them, and till now no agreement has been reached, but we don't lose our hope.
Okay, thank you. Are there more questions? Final questions to the presentation? Okay, Stefania, thank you very much. Oh, there was one. Sorry, I didn't see it. Sorry.
I noticed that the validation is against GML 3.2, but the current INSPIRE schemas are GML 3.3.
No, dot 1. 3.2.1.
Yeah,
Yes.
but the current...
It is not written, but the name of the original GML test suite is GML 3.2. But it's validating against
But the current schemas is 3.3. Have you considered upgrading the validation?
Current INSPIRE schemas versions 4 are not against INSPIRE the GML 3.3.
Okay, any other...
When there will be, we will
I'm not too sure, to be
update.
honest, I'm not in that. So it's
I think it's still 3 to 1.
Yes,
okay,
it
so
is. It is. It's not yet. It is foreseen. So when it will be, we will update accordingly.
However, 3.3 does not remove anything.
Yes, yes. Just adds, right. So it would be fun. It would work
it
anyway.
could possibly work for both if you had. Okay.
Yeah.
Okay. Thank you for that clarification. Thank you again, Stefania.
So you're welcome.
Yeah.
That's it. Okay.
Thank you also for being around for further questions on your stand. And we move on to the final presentation from Antonio Rodriguez from CNIC in Spain. And he will tell us about interoperability evaluations for geoportals, different geoportals, I guess, in SDIs. Might like to start first.
Okay.
Stay here, please. I keep the auditorium, Antonio.
Okay, let's see. Oh dear. Okay.
Well done.
Thank you.
That worked.
Okay, thank you very much. Good morning to everybody. We want to speak a little bit about a quite simple analysis we have performed on national geoportals all over Europe and to share the results with you. Okay. We're going to speak a little bit about the justification or purpose of our study, to explain very briefly the methodology applied, to explain the set of indicators we have used, and to comment the results with you. Well, first of all, we think that most of the effort of standardization and harmonization has been invested until now on the server part, on the services, but a very few attention has been paid to the client part and geoportals. And we think are a very important part of national spatial data infrastructure. So the purpose of this little study has been to define and apply a set of indicators about usability and interoperability of geoportals, mainly to try to measure in some way, to evaluate the quality of national geoportals. For us, a geoportal is something similar to a store window of resources. I think it's a place where developers, brokers, and integrators of resources look for services, resources, and so on to build an application or a service. So, we as CNIG have some experience on America, Spain, and Europe geoportals quality assessment since 2008 in courses and seminars to show geoportals and evaluating how things are done. After that, we have defined 19 indicators, and we have launched an inquiry among 33 SDI experts to get feedback. We have got one indicator more and weights for the indicators.
We have, you can see there the distribution of the people consulted, 16 people from public sector, 8 from private sector, 9 from university, and especially 18 experts from Spain, 7 from Europe, and 8 from America. Well, we want to warmly thank to all the experts we have answered our questionnaire. And we have evaluated 35 European national SDI Geoportals with these 20 indicators, pointing each one of them from 0 to 10. Looking at geoportals like looking for the definition in the directive, an internet site providing access to INSPIRE services, and with that approach, looking the geoportal as the way where resources shall be exposed to be used or integrated. It's not mandatory to have a national geoportal. The directive only mentions the point, but I think it's very recommendable. I think it's a good idea. The first problem is to find these national geoportals. It's not so easy. Where are the national SDI INSPIRE geoportals? INSPIRE Monitoring and Reporting Archive shows information about all the countries, but we can find one dead link, 9 countries without URL, some URLs pointing to administrative portals, no technical geoportals, so it's not so easy. Eurogeoinfo.org includes national SDI, INSPIRE, and geoportal links for each country, but it's not fully updated, and it's not also the solution. So there is no website describing the European National SDI Geoportals network nowadays. I think it's a first very serious problem. Well, you can see the list of the 35 NSDI geoportal considered, all the URLs. And the second problem is that sometimes not having an English version, a lack of usability, or to find more than one portal for each country is also a problem to try to perform such a study. So it makes very difficult to complete some kind of evaluation or comparison. Well, you can see very quickly the 20 indicators are quite simple to use OEC standards, availability, openness, performance, identity, to declare the body responsible for the geoportal, because I think this is very important to give more credibility to a geoportal or not, to give visibility to the resources in the national SDI, to have legal info, and so on. We can see the indicators ordered by the weight provided by the expert consultant. The first of all was OEC standardization, and the last one, no logo. The criteria or not having any commercial brand in URLs or in any inappropriate place. The weights are also from 0 to 10. Well, here you can see the evolution of the average weight for each indicator, taking into account more and more experts. And that's a way of saying that, well, 33 experts are enough to give a good average, because one expert more moves the weight for an indicator only 0.1, no more. So I think it's a good number of opinions. The evaluation methodology has been extremely simple as a first approach. For example, for multilingualism, UK, Ireland, and INSPIRE geoportals has been not evaluated because are in English, obviously, and there are one indicator less. If there are a core English interface, you get 10 points. If there are an English interface, but we find problems in the first page, only 3. And if there is no English interface, 0. So quite simple. Or browsers. Try to open the geoportal and the viewer or the catalog using Firefox, Explorer, Chrome, Edge, and Safari, and 2 points each one. That's all. So quite simple and objective. Or usability. To publish the result of a usability study and have a web map, a sitemap, 10 points. To have a sitemap, 5 points. Nothing, 0. Okay, quite simple method of evaluation. You can see, well, it's quite a small wording, but I think then you can get the presentation and you can see all the methodology for the 20 indicators. Well, and last, we can see the results. Here in blue color, a good result, green, intermediate, and red, not enough, less than 5 points. Well, some indicators are quite okay, but some of them has not very good results. For example, the usage of OGC standards in the viewer. It's strange because some viewers use other interfaces, or to give visibility of the resources of the national SDI, to give the URL of services and the URL of the nodes under the national node and resource visibility. The result is not very good. Of usability. Usability is not one of the strong points. And also the diffusion, I think, is a very silly question, but it's quite difficult to find all the geoportal addresses looking in Wikipedia geoportal or SDI, or looking at global SDI, the page of GSDI or UNGGIM. Okay, or accessibility is also a problem. Multilingualism sometimes is a problem. There are few portals with no English version, and social networks are very, very few used to give publicity of these key resources, as is a national geoportal. Some conclusion. Please have an English version. So it is a good idea to pay some attention to Safari, because there are some very particular users using this browser. Then please test your portal using HTTP and HTTPS, because sometimes it doesn't work with one of those options. Declare clearly the body responsible for a geoportal, because sometimes it's not so clear. We think it's a good idea to implement a gazetteer, not only for administrative units, for all kinds of features, to find things in the viewer. Promote your geoportal in Wikipedia, in GSDI. Consider to use Twitter and social networks to give publicity to your national geoportal. Use OEC standards in your geoportal. Explain use conditions, not always are explicitly declared. Look for your geoportal in search engines. I think, is the geoportal of your country easily findable if you look for it in Google or not? Make your resources visible. And this is under our approach. We see the National SDI Geoportal as a place where developers and integrators can find all the resources in the extent of SDI. Also, we have got some very interesting feedback from the experts consulted. For example, introduce findability as a new indicator, as has mentioned by 4 experts. Also, a more detailed evaluation for some indicators or usability has been demanded. It is very important to use social networks. Consider also as minimum and as a part of the minimum set of services, download services, WFS and Atom. Split and join some indicators. Some reorganization has been proposed. I think there are several indicators we have used regarding very similar aspects. Also, we have detected some variety of opinions, so not unanimity, and some people think about a national SDI for advanced users, and other people think about a geoportal devoted to give service to naive users, to end users, to citizens. There are 2 different approaches. I think the first one is priority, in my opinion, and the second one must be the second objective. And some very simple recommendation is, at national level, to have a unique national SDI Geoportal in each country, giving easy access to all the services and resources in the national SDI scope, with an English version, and maximize usability, and to have a only website with a Geoportal part, a third part devoted to legal and organizational information, or to have two very coupled websites with links to link one watch each other. And at European level, we think it's very recommendable, it's a good idea to have a national SDI Geoportals directory in INSPIRE website to find all the resources very easily, and this is for guarantee the visibility and navigability of all the resources network. Well, first of all, the total indicator, adding all the evaluation with the weights proposed by the expert, is summarized in the figure you can see. The total result is quite good, but there are some geoportals with a little bit low punctuation. At the end, the general quality of INSPIRE Geoportal is quite good. We found good availability, performance, responsiveness, but it will be very easy to improve some aspects, like the use of OSC standards, the identity of the body behind the geoportal, the legal information, the resources visibility, the usability, the auto-definition as a SDI geoportal, and the feedback. We think the rest of the aspects are also recommendations, and we think all of the aspects considered are important. And that's all. Thank you very much for your attention.
Thank you very much for your presentation, a very pragmatic approach and some useful hints to some of possibly. Are there questions to the presentation or comments, addings, please?
As a user of Geoportal, thank you. As a user of Geoportal, I think sometimes it's difficult to find the information I need in. What kind of tests do you think it's important to do to ensure that the search is good quality?
Do you mean the search facilities in a Geoportal?
Yeah.
Well, there must be necessary to perform a full usability test. So that need to invest quite a big effort and time. We have performed here a very, very simple test, but it will be necessary to design a full usability testing methodology, apply them with group of users, with several tasks, and so on. Yes, but I agree with you. In general, search utilities in Geoportals are not very easy to use. Yes.
Okay.
Mm-hmm.
Okay. Are there further questions or comments? Just as a hint, there is some work on usability and there are publications on that, so I can give you some hints on that one later on. Further questions, comments? Please, go ahead.
Are the results published?
Are the results published or publicly available?
Well, yes, I am planning. We're planning to write a full article and to send to SDI Research, magazine. Mm-hmm.
Good to hear that.
Yes, but anyway, if any people belonging to the team responsible for a national SDI wants more information, just please send me an email. I can send you all the information. Okay.
Okay. Then also the less diplomatic version, I guess, is something that you would get there.
Okay.
Okay. Thank you very much.
Okay. Thank you. Thank you.
Thank you for participating in the discussion. You have now a coffee break for the next half an hour, and then you all join, I guess, for the plenary. Enjoy the day.